Hello, ladies and gentlemen. Today we will be talking about order of operations, and we're going to begin with the problem that you see on your screen. So let's go ahead and get started. All right, so in this particular problem, I'm going to first of all break it up into a couple different pieces. Anytime where I see a plus or a minus sign that's not inside parentheses, that's what I'm going to use to kind of split my problem into parts. So I'm going to go ahead and draw kind of like let me actually use a line tool here to kind of separate it. I'm going to go ahead and separate this problem into two pieces. So I have this problem over here, and then I also have this problem over here, and when I get values for those, then I'll go ahead and subtract the value and get a final answer. All right, so if you recall, when we're doing order of operations, we need to use our rule, which is the PEMDAS acronym. And if you recall, the P in PEMDAS always stands for parentheses. So if we see any parentheses in the problem, we always do any math that's inside the parentheses. Clearly, we see parentheses in this problem. We have the operation subtraction inside it, so I'll go ahead and do the operation. We have 5 minus 1, which gives us a value of 4, which, by the way, is getting squared still, so we'll deal with that upcoming. And then that's getting divided by 8. And then we still have, of course, minus the 3 cubed. Okay, so if I don't see any more parentheses, I can check that off my list and move down to the next choice, which is exponents. So now I'm looking for any exponents in my problem, and I always work from left to right as I go through this problem. So the first exponent that I encounter is 4 squared. So 4 squared is not 4 times 2. That's a common mistake. 4 squared means 4 times 4. 4 times 4 is 16. And of course that's getting divided by 8. And of course that's being subtracted from 3 cubed. While I'm here, still on the exponent level, let's go ahead and figure out what 3 cubed is. Now again, that's not 3 times 3. That is 3 times 3 times 3, or 3 times itself 3 times. So 3 times itself 3 times gives me a value of 27. All right. Now that I have 16 divided by 8 minus 27, I don't see any more exponents, so I'll check that off my list. And now I'll look for multiplication or division. Either one. These are interchangeable with one another. And as I work my way left to right across the problem, whichever one of those I encounter first is the one that I do first. And I only have a division in this problem, so I'll go ahead and take care of that right away. 16 divided by 8, of course that gives me a value of 2, which of course I still have to subtract 27. So as I look, this is all I have left. I don't have any multiplication or division left, so I'll check that off my list and move to the final stages, which is addition or subtraction. All I have left is subtraction, 2 minus 27. Now I realize a lot of you have difficulty when you have a small number minus a big number. Well, if you'll think of it this way, we know what 27 minus 2 is. I mean, we've known that since second grade. 27 minus 2 gives you 25. Well, if you think about it, 2 minus 27 is kind of the opposite of that. So it would make sense that our answer would be the opposite of 25, which would be negative 25. All right, let's look at another question. Ooh, this one looks pretty scary to me, but you know what? If we take it one piece at a time, it's not a difficult challenge for us because we all know how to add, subtract, multiply, and divide, and literally that's all that's happening in this problem. All right, let me go ahead and divide it up into pieces wherever I see addition or subtraction pieces that are not inside parentheses. So I have this piece right here, and then I have this one right here. So this is kind of like 3 separate problems here, right? I've got the 9 that's sitting by itself over here, and then I have the 5 times 3 minus 4 squared, and then I have 2 to the 4th minus 17. So we're going to begin with parentheses as we always do. So my first set of parentheses, as I work myself left to right across this problem, I see 3 minus 4. Well, again, I have a small minus a big, and if I think the way I did in the last problem, I know what 4 minus 3 is. That's a positive 1. So it would make sense that 3 minus 4, which is the opposite of that, would give me the opposite of the answer, would give me a negative 1. Now, that's still getting squared, and there's still a 5 on the outside of that. All right, and we still have to add right here. And now let's look at what's inside this parenthesis. So this parenthesis has a couple things going on inside it. We have 2 getting raised to the 4th power, and then we have the 17 that's being subtracted from that value. And so this is kind of its own little mini world. This is its own mini problem, and we have to follow order of operations inside this little mini world as well. Do we do the subtraction first, or do we do the exponent first? Well, we know that we always do exponents before we do any subtracting. So let's figure out what 2 to the 4th power is. 2 to the 4th power is going to be 2 times 2 times 2 times 2, which I believe gives us a grand total of 16, which is being subtracted from 17. Now, as I continue to look through my problem, I still have parentheses. Now, this first set of parentheses, there's really no math to do inside the parentheses. Those parentheses are just kind of setting us or letting us know that the 5 is being multiplied to that value. So I don't have any math to do there. So I'll go on and work on this last set of parentheses, which is the 16 minus 17. Well, 16 minus 17, again, I have a small minus a big. 16 minus 17 would give me the value of -1. All right, so I think I've cleared away all of my parentheses. Now I'm going to be looking for any exponents in the problem, and I only see one exponent right here, where the -1 is getting raised to the 2nd power. So that's literally saying -1 times -1. Well, we know 2 negatives make a positive, so my answer must be a positive answer. 1 times 1 would give me a 1. And again, I have the 5 right on the outside of that, and then I still have the 9 in the very beginning, and I have this -1 at the very end. So I'm done with my exponents. I don't see any more of those. Now I'm going to be looking for any multiplication or division in my problem. I don't see any multiplication signs, but I do have multiplication, and it's right here. If you don't see an operation sign between a number and a parenthesis, it's presumed to be multiplication. So this 5 is being multiplied to the 1. Very easy multiplication for this one. It just gives us the value of 5. I'll fill in all the other stuff that we have here. I don't see any more multiplication or division in this problem, so it looks like that's finished. The last thing we look for is any addition or subtraction, so kind of like the railroad tracks. And again, these are interchangeable as well. As we work our way from left to right across the problem, if we encounter subtraction first, we do subtraction. If we encounter addition first, we do addition. And I do see subtraction first immediately. I see 9 minus 5. So 9 minus 5 gives me a value of 4. But then I still have this plus a -1 to deal with. So that's the last piece of my problem, 4 plus a -1. Well, 4 plus a negative, these two together, as you probably know, just turn into a minus sign. So essentially, 4 plus a -1 is the same thing as 4 minus 1, and 4 minus 1 gives us a value of 3. All right, let's keep going here. We're on a roll. Let's take a look at this next question, which might freak you out a little bit because we see a square root, we see these absolute value symbols, but don't sweat it, it's a piece of cake. Again, we're going to follow our PEMDAS rules. Always, always, always must do this in the correct order. That's why it's called order of operations. So the first thing we look for is parentheses. Now I actually see parentheses right here, but there's no math to do inside it. It's just a number sitting inside the parentheses. I don't see any more parentheses, but there actually is something that we need to treat like parentheses in this problem, and that's these absolute value symbols. So if you see absolute value symbols, you have to treat them as parentheses as far as when you apply that math in the order of operations. So let's go ahead and work on what's inside these absolute value symbols. So I have a 49 getting square rooted, and then I have minus 10. And according to the small world of order operations inside these absolute values, the first thing I would take care of is the square root, because that behaves kind of like an exponent would. So we need to figure out what number times itself would give us 49. That's the square root of 49. Well, we should remember that 7 times 7 gives us 49. So the square root of 49 is 7. So we still have the minus 10. And then we still have this divided by -3. All right, so now let's continue working with our absolute values here, working with those pseudo parentheses. 7 minus 10 is actually a negative 3, but it's not going to stay negative very long because it's sitting inside absolute value symbols. And if anything inside an absolute value becomes a positive value. So a negative 3 absolute valueized turns into a 3. And then all we have left is doing a little bit of division with this negative 3. 3 divided by a negative 3, well, we have a positive divided by a negative. That's going to give us a negative answer. And 3 divided by 3 gives us the value of 1. All right, keep on keeping on here. We're going to look at one more question. Ooh, this one's got stuff on the top and stuff on the bottom. Well, I would suggest you treat this as two separate problems. We work on the value on the top, get a value, then we work on the value on the bottom, get a value, and then we do any division or simplifying of a fraction. So let's rewrite the numerator over here. I'll put negative 1 cubed minus 4, and then parentheses 1 minus 4. And just like before, I'm going to go ahead and kind of create those railroad kind of track things here to separate the problem into two pieces. Wherever I see plus or minus or addition or subtraction, it kind of breaks my problem into parts. So I have the negative 1 cubed, that's one problem, and then I have 4 parentheses 1 minus 4, that's another problem. And again, we are always going to be following our order of operations, PEMDAS. So let me write that down off to the side, and we look for any parentheses in our problem. And I do see right away 1 minus 4. 1 minus 4 gives us the value of negative 3. And you might be wondering, why did I keep that in parentheses there? Why did I not just put a negative 3? Well, this 4 is connected to this thing, this 1 minus 4, by multiplication. And if I just put 4 minus 3, it would look like I'm subtracting 3 from 4 instead of doing multiplication here. So it's very important that you leave those parentheses there so that you remember 4 is being multiplied to that negative 3. All right, since I don't have any more parentheses, I can check that off my list, and now I can look for any exponents. And I do see an exponent. I see negative 1 getting cubed. So what that means is negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1 times negative 1 is, you guessed it, negative 1. And that's still getting subtracted from the value 4 times negative 3. No more exponents. Check that off my list. Now I look for any addition or multiplication or division, I do see multiplication right here as I work my way from left to right across the problem. 4 times a negative 3. Well, positive times a negative should give me a negative answer, so negative 12 is the result of that. I'll fill in everything else. I don't see any more multiplication or division. All that's left is addition or subtraction, and I have subtraction. I have a negative 1 that's being subtracted from a negative 12. Well, you should remember when you see two negative signs right next to one another, together these two signs turn into a, you guessed it, a plus sign. So essentially, negative 1 minus a negative 12 is the same thing as negative 1 plus 12. So a negative 1 added to 12 essentially means we're going to be taking 1 away from 12. And taking 1 away from 12 would give us the value of 11. All right, we have one more problem to do. This involves fractions. And again, we need to make sure we're following our order of operations when we're doing this problem. Now, there's not a whole lot of craziness looking in this problem, but we do need to make sure we do it properly. I don't see any parentheses. I don't see any exponents. Now I'm looking for any multiplication or division, and I see that right away. I see multiplication or division right here. So let's focus on finding out the value of this 8/9 being divided by 2/3. If you'll recall, when you divide two fractions, you keep the first fraction alone, you turn the division into multiplication, and then you flip the second fraction. So now if we were to multiply these two together, you multiply the tops, you multiply the bottoms, you get a value. Before you do that though, I recommend you do some simplifying here ahead of time. Now we can't simplify 8 over 9, we can't simplify 3 over 2, but we can do some cross or diagonal simplifying. We know that 3 and 9 both have the common factor of 3. 3 goes into itself one time, 3 goes into 9 3 times. We also know that 8 and 2 have a common factor. That is 2. 2 goes into 8 4 times, and 2 goes into itself 1 time. So now when I multiply these two together, I have 4 times 1, which gives me 4. I have 3 times 1, which gives me 3. And now I still have to add the 3/4 with my 4/3. Now, a lot of kids would be like, 3 plus 4 is 7, 4 plus 3 is 7. That's my answer. That's not the right way to go about it. If you recall, when you add or subtract fractions, we have to get a common denominator. And the easiest way to get a common denominator is literally to multiply the current denominators, 4 times 3, giving us 12. So we're going to be changing both of these fractions so that instead of having a 4 here, we have a 12. And instead of having a 3 here, we have a 12. Now, how does a 4 turn into a 12? Well, 4 turns into a 12 by multiplying it by 3. And if we multiply the bottom of a fraction by 3, we also have to multiply the top by 3 as well. Otherwise, we're changing the value of the fraction. 3 times 3, that gives us a 9. All right, so over in this next fraction, a 3 turned into a 12. How does a 3 turn into a 12? Well, we had to multiply that by 4, which means we also have to multiply the numerator by 4. 4 times 4 gives me 16. Now that I have common denominators, I can go ahead and add my numerators. 9 plus 16 gives me 25 over 12. And if I want to write it as a mixed number, I know that 12 will go into 25 2 times with 1 left over. So there's my final answer. All right. I hope that this review of order of operations helps you when you get to your SOL test. Have a great day, everybody.